Hello, everyone. We are from the DOGE Price Predictor group by our 42 project. Today, I'm going to present our results from predicting Dogecoin prices. And this is our agenda for today. And let's first of all talk about the background of Dogecoin. So Dogecoin is essentially or initially created in 2013 as a meme to poke fun at Bitcoin, which at the time Bitcoin was starting to rise drastically. But in 2021, Dogecoin became one of the 10 biggest cryptocurrencies by market cap. And according to Coinbase, its total value has topped $50 billion, even though each individual coin is worth pennies. So what is our motivation behind our decision in this project? So in the event of 2021, when Dogecoin begins to rise in value, it begs us to wonder what drove Doge prices to increase so dramatically. These reasons behind its increase is essential for us to understand the role that cryptocurrency can play in years, especially if people want to invest, making future investments. But why we do use machine learning? Because machine learning can allow us to see hidden patterns in the data set, linear or nonlinear, within the data that may not be very obvious. And in the future, machine learning can allow us to make predictions and forecasts on future data points, which is something cannot be done with simple maths.
So for our data set, we looked at a lot of different sources online to end up constructing and curating our data set. Next slide. We ended up using a lot of data from the Reddit social media platform to figure out how many comments there were or posts there were in a certain time period with the term Dogecoin. We used investing.com, finance.yahoo.com, and Fred Economic Data to look at Bitcoin prices, Ethereum prices, and other cryptocurrency prices, as well as the prices of commodities like crude oil and stock prices like NVIDIA. We also got the inflation rate. We also used Google Trends to figure out the search index of Dogecoin on any particular day. And we used Kaggle to get some curated data sets about Elon Musk tweets and Dogecoin tweets. Next slide. Our final data set ended up being 1149 rows with a granularity of 1 row per day from 2017 to 2020. And it included things like the high price and low price of various cryptocurrencies and stocks, as well as the number of times a word was searched in a certain day or a word was mentioned within a Reddit comment or a post.
So some of the models that we use include supervised models and unsupervised models. For our models, which are supervised, we included a little bit of seasonality and autoregressive features. And as for the random forest, boosting, and cart, we did cross validation for all of those.
So first of all, we built a multilinear regression in order to identify underlying linear trends. We did the feature selection by using VIF values less than 10 and p-values lower than 5%. And the features selected are on the leftmost column of the results. And we noticed that the coefficients for the features are mostly close to 0, which means that holding all parameters the same, changing only one parameter by itself shouldn't have much influence over Dogecoin high prices. We yielded an R-squared value of almost 98% with this model.
So when doing boosting with cross validation with max leaf nodes of 10, after doing cross validation, we found that having a maximum of 6 leaf nodes and is best. And for feature importance, it was found that the Dogecoin high yesterday was of the highest importance. And as for the seasonality, it was not useful. And the other features had marginal importance. And that can be visualized within the test set graph in the left side, where you can see that the prediction is lagging behind the real values. However, it is not entirely useless, as we can see from the OSR squared that it is quite high.
Okay, moving on to random forest. This time we're also doing cross validation, where the hyperparameters that we are cross validating over is the max features. And after running this cross-validation model, random forest model, we got the best R squared of 0.96 and the best and the OSR squared of 0.91, which is not the highest not the highest than rather than the previous model, but it's also kind of high. It also represents the graph on the slides. If you can, as you can see, the green line is the predicted value of Dogecoin, and it fits pretty well to the real value, which is represented by the black line.
Moving on to the CART model, we used CART with cross-validation to cross-validate the number of features and found that the optimal number of features for the CART model with a max depth of 5 was 5 features. Next slide. In our CART model, the very top split was for the high Ethereum price, indicating that that was a very important decision-making factor for our model when predicting the price.
For our results, we can see that multilinear regression does have quite an high OSR squared, with CART lagging just a little bit behind. It shows that all of our models have they're quite predictive of the value of Dogecoin. But if we look at this graph, we can see that multilinear regression has the highest OSR squared, showing it is very predictive of the Dogecoin value, while it also has a low variance when being bootstrapped for OSR squared. While we can look at boosting, and it has an incredibly high level of variance, while also having a low OSR squared. And as we saw in the previous graph a few slides ago, it also lagged in predicting. So we can see that how these different models have varying and levels of quality, and which ones have greater predictive ability.
So we expanded on our current models because it was unclear how the different features that we had obtained interacted with one another. For example, we were curious if we could derive any relationships between some of the social features that we had obtained with some of the economic and financial features. To do this, we opted for k-means clustering to visualize any underlying patterns within our data set. We use an elbow plot to determine the most optimal number of K, and we found that our entire data set could only be visualized into 3 or broken down into 3 clusters. Unfortunately, this approach did not offer any meaningful clusters because there were a lot of features. And so we proposed that an area of future improvement and analysis is combining PCA with k-means clustering to better identify the clusters to gain more meaningful insights. Additionally, it would also be interesting to evaluate how our findings can translate to other cryptos, which would be beneficial in understanding the limitations of our model and identifying how different cryptos behave over time under external influences.
Moving on to potential impacts of our results. Our analysis concluded that both linear and nonlinear models can be used to identify relationships between Dodge prices and the features we studied. And our results show that the decision tree model has the best performance out of all models because it has both high accuracy and high interpretability. So the treaty tells us that analyzing Ethereum prices is the best way to determine Doge prices. That means that fluctuations in Ethereum prices can provide insights about changing trends in Doge prices. And the application of our results can have an impact on, first, a professional setting as a first pass at analyzing what influences Doge prices. And secondly, our model is a great visualization tool for beginners in crypto because it's informative of what factors to consider when investing in crypto. With that, we end our presentation. Thank you so much for your time.
Thank you.